The students, actually, the video got cut. This is the continuation of the alkalinity. So first thing is, if this P is 0 means hydroxide is 0, carbonate is 0. So whatever total alkalinity or the methyl orange you get, it will be the bicarbonates. Is it okay? Let me check the video is still on or not. Yeah. Now, next point is, let's increase the P a little bit. So if say P is not 0, but it is less than total by 2. Total by 2. It is less than total by 2. Okay. I won't have much space. So P is less than T by 2. Okay. Let's say, for example, P is equal to say 2. So T by 2, less than 2 by 2 means total may be around 6. So T by 2 is equal to 3. Am I correct? That means P is less than T by 2. So total will be 6. If P is 2, T is 6 means M is methyl orange will be 4. Am I correct? So this will be like phenolphthalein is 2 and methyl orange is 4. In below upper it is 2, below is 4. I'm just giving an arbitrary example. If 4 is there means it's very sure that both the ions are present. Am I correct? However, on the top only 2 is present means here only one of them will be present. Because if both are present, if this is present, this will be present. If this is present, OH cannot be present because one is acid, one is base. So if P is less than T by 2 means OH is 0. So this is 0. And then what about the CO3 2 minus? CO3 2 minus is the phenolphthalein part, half into 2. So CO3 2 minus can be twice into phenolphthalein. Whatever you got in phenolphthalein, you multiply by 2 times, that is your carbonate. Okay? What about bicarbonate? It's very example. Easy. Total minus 2P. Whatever total you got, say 6 minus 2P. 2 2s are 4. 6 minus 4, 2. 2 will be the bicarbonates. Okay? Number 3 is, let's say P is equal to T by 2. If P is equal to T by 2, that means, let's say P is equal to 3, T is equal to 6. So the upper part is up also 3, below also 3. This is also 3 equivalent, this is also 3 equivalent. If OH is present, this cannot be present. So if this is not present, below is 3. So carbonate should be there. If carbonate is there, up also carbonate should be there. But both of them are 3 and 3. Then OH cannot be there. So up and below both are same means, since all the 4 cannot be exist together, only this and this are present. So OH is equal to 0. And then bicarbonate is also 0. So CO3 2 minus is a total itself, or is equal to twice P itself. So T is equal to twice P, same. Okay? So look the video again, rewind it, you will grasp it. Now, the next one is P is greater than T by 2. P is greater than T by 2 means, let's say P is equal to, say, around 7. Total is around, say, 10. T by 2 is 5. So 7 is greater than 5. That means on the top, 7 is present, and below, if total 7 is present, below will be 3. Correct? So 7 means 7 is greater than 3. That means both the ions are present. So below 3, since OH and bicarbonate cannot be present, this HCO3 is 0. Okay. So first of all, wherever is 0, you put it. This is 0. What about CO3 2 minus? What about 3 is half of CO3 2 minus, whatever 3 is there. So can I say CO3 means there is T minus P. That is methyl orange. This methyl orange part, it is the half of the carbonate. So total carbonate means again on top it's there. So you can say twice 2 minus P. Okay. So what about OH? OH is the last one is T minus whatever carbonate is there, twice T minus P. That is T minus 2P is minus 2T minus minus plus, so it's equal to 2P minus T. Okay. The last one is if P is equal to T. Okay. If phenolphthalein is equal to T. If phenolphthalein is equal to T means, if this is T means, as simple as that, there is no methyl orange. P is equal to T. Total is P means there is no methyl orange. So carbonate, bicarbonate both will be 0. Both of this will be 0. And this is P is equal to T. Whatever left. Correct? So from this condition, you can find all the 3 ingredients as per the condition of the P and the relation of T. This is a chart. Now I'll do one example. Okay. Now we'll do just the last numerical for alkalinity. Okay. So for the alkalinity case, see one question is there. Question: a sample contains 122 milligram per liter of bicarbonates and pH is equal to 7. Is it okay? No. I'll give you another very simple example. One very good example is there. Forget it. Now, what I said is a water contain carbonate is 210 milligram per liter. Whatever, sorry. 210 gram. Bicarbonate is 122 gram and OH is equal to 68 gram. What is the total? What is total alkalinity? Okay. So you see over here, what to do is CO3 is 210 gram. Now, if you want to mix these 3 together, you have to convert into milli equivalent. Convert to milli or whatever equivalent. Okay. So 1 equivalent of CO3 2 minus is equal to, which is 12 plus 16 into 3. Excuse me, this is 60 gram. Therefore, 210 CO3 2 minus is equal to 1 equivalent is equal to 60 gram. So 1 by 60 into 210. Correct? This is 6 by 21. 6 3s are 18. 3065. 3.5 equivalent. Number 1. Similarly, number 2, carbonate. 122 gram of bicarbonate is equal to 1 by, what about bicarbonate? This is 1, CO2 minus plus 1. So I can say 61. 61 into 122 is equal to 2 equivalent. CO3 is already 60 plus hydrogen 1 is 61. Okay? Then number 3 is OH. 68 gram OH is equal to 68 divided by, OH is 16 plus 1, 17. So 17 to 34 is 4 equivalent. Fine. Therefore, total is equal to 3.5 plus 2 plus 4, 6, 7, 8, 9.5. Okay? Total is 9.5. Let me finish this part. Therefore, total is equal to 3.5 plus 2 plus 4 is equal to 9.5 equivalent. Is equal to 9.5 into 50 grams per liter as calcium carbonate. 9.5 into 50 is 475 grams as calcium carbonate. So this is the total alkalinity. Is it okay? Another one to find OH is if pH is equal to say, if you say phenolphthalein alkalinity is 0, that means hydroxide will be 0, but hydroxide cannot be 0. I'm giving you an example. If pH is below 8.3, then say if pH is equal to 8.1, say for example, here we say no phenolphthalein. That means OH, I told you, is equal to 0. But actually, this is also not correct, insignificant. So pH is equal to 8.1 means POH is equal to 14 minus 8.1 is equal to 5.9. Therefore, OH is equal to 10 to the power minus 5.9. Is that okay? If POH is 5.9, OH will be 10 to the power minus 5.9. This is equivalent, molar concentration. Okay, now you want to convert into milligrams per liter? Let me do it over here again. Now you see 1 equivalent of OH is equal to 16 plus 1 is equal to 17 grams. Correct. Therefore, 10 to the power minus 5.9 is equal to equivalent is equal to 17. 1 equivalent is equal to 17 grams. Therefore, this much equivalent is equal to 17 divided by No, it should be 17 into 10 to the minus 5.9 grams. Is it okay? 17 into 10 to the power minus 5.9 grams. Correct. So if you want to convert into milligram, it can be 17. Sorry. Let it be. So is equal to 17 into 10 to the power minus 5.9 into 10 to the minus 3 milligram plus 3 milligram. It's equal to 17 into 10 minus 2.9 milligram. It's equal to 17 into 10 to the power minus 2.9. Till minus 9 or 10 into, so it's equal to 0.021 milligram per liter of OH. Okay, see 0.021 milligram per liter of OH means it is very insignificant, almost to zero. But this is the way to estimate. Is it okay? So now I have estimated the pH, the alkalinity, and the titration concept. Now, after finishing this, I'll ask you all the students the question, and then for the titration of hardness, the BOD, the COD, and the chloride, just in another 10 minutes in my next class, I'll continue it. Okay? So this is for the alkalinity and the pH. Thank you.